stored at address 7000, the compiler will simply generate the code to call the function at 7000. Okay? So what's the benefit of that? Benefit is the code will run pretty fast because it will directly go to the function, make the call. Okay? What's the danger of that? The danger of that is, in this case, it's calling the wrong function. Okay? The programmer actually allocated my compute, so it should be this one that should be called, right? So C# at least gives you a warning. Are you sure you want to do this? So you'll get a warning. So anyway, so that's why you will mark it virtual. And now, what's the penalty we are paying for this? The penalty we are paying is there's quite a bit extra code. It has to go over here, find the vtable pointer, go to the vtable, locate the function, then make the call, right? So coming back to Java, why Java does not have virtual keywords? See, when Java was created, the designers of Java thought, let's not confuse the programmer, okay? Let's make programmers' life easy, so all public functions in Java. So if you create a class, you write a public function, are virtual by default. So that means every time you make a function call in Java, it will go through the vtable, okay? Whereas designers of C# thought, okay, what if you're not using inheritance? Okay, why should we slow things down? Why should not we be able to call it? And same thing in C++. So C++, you have an option also, whether you use the virtual keyword or you don't use the virtual keyword, right? But anyway, so hopefully now you understand what those three keywords mean and how they help us in writing code where the programmer's intention is not is followed. Okay, go ahead.
So in Java, there is a keyword for the super keyword, right? For referencing
for the base class.
For the base class.
Correct.
If all the classes are marked virtual, then how does the super keyword work actually?
Well, super keyword has a totally different goal. So for example, let's say you created some base class. You wrote, let's say, 3 functions, right? Suppose I call them F1, F2, F3, right? And now from here we inherited, so let's say this is class A. Suppose this is class B. So we inherited or extended this class, right? Okay, so now suppose I have some function over here, F5, which has nothing to do with inheritance. And suppose this wanted to call F3 as an example. So using the super keyword, you can say super.f3. So, so that's a capability to call any function in the base class. In C#, what's the equivalent of super? Base. Okay. So anyway, so now let's come to the next concept in finishing our basic object-oriented programming.
I have a question.
Sure.
If we make the method virtual in a base class, but
Uh-huh.
we didn't override that method in derived class.
Okay.
So how?
What happens to that method?
Yeah.
Okay, good question. Let me answer that. Okay, suppose you created a class. Again, whatever x, y, z. You created some method over here, let's say F1, and you marked it virtual. Okay? Then from here you created another class, let's say PQR. Okay? And you did not override F1. Okay, so no override of F1. Okay? So so what that means is, remember, once we inherit everything. So this method is also over here, even though we did not override it. And it continues to stay virtual over here. Okay? So if you go further down, here you can do an override on F1. Okay? And if the compiler And if you wrote some code, let's say PQR, P1 equal to new, let's say, suppose this is LMN or whatever, new LMN. Okay, so, and then you did P1.F1. Okay, so again, what the compiler will do is start from P1 and come over here to see if there's F1 declared. Okay, there's no F1, but it's inheriting from XYZ. So the compiler will go to the base and see is F1 declared virtual. If it is declared virtual, it will generate the code to go through the V table and call this correctly. Okay? Okay, so now we need to move to the next important concept in, again, basic OOP. So like I said, hopefully end of next week we'll finish the basic OOP. Then we'll move to the intermediate level object-oriented programming, and then the advanced OOP. So that's how we are progressing. By the end of the course, you'll be top-notch programming expert. Okay, so anyway, it's very important that our foundation is good, so we are spending some time on these basic concepts, even though many of you already hopefully know these concepts, but no harm in strengthening these concepts. So, coming back over here, now we know exactly what encapsulation means. This is the class mechanism, the public, private, protected type of keywords, right? Inheritance, we exactly know how it works. How do we create classes? The concept of abstract, virtual, override, static, so everything hopefully should be clear. Okay, so now let's come to the next concept over here, polymorphism. Okay, so polymorphism, first let me explain the plain English language meaning of it. Poly means what? Many. Morphism basically means forms. So what do we mean by polymorphism when we apply it to programming? It basically means many forms of a function or method. Remember, function is also called a method in object-oriented programming. So that's all it means. Further, what do we mean by many forms of a function so all this means is more than one function with same name. Okay, so technically speaking, okay, even though some people may disagree with me, but there are three different categories of polymorphism. Okay, one is called, see, you guys have already seen more than one function with the same name. For example, remember whenever we were writing constructors, constructor is a function, right? So we had more than one constructor. We discussed typically we'll write two constructors, one without parameters, one with as many parameters as the fields inside a class, right? Okay, so anyway, over here, so function overloading. So whenever we write more than one function, it has the same name, we also call it overloading. Okay, so now overloading is always done within the same class. Okay, so again, very quickly to give you an example, let's say you created some class XYZ. Okay, you wrote some method over here, double, let's say public double compute AVG, int A, int B, int C, right? And you did return a plus b plus c divided by 3.0. Okay. Now, can we write one more compute ABG in the same class, which takes 4 parameters instead of 3?
Yes.
Yes, right? So if I went to the same class and I said public double compute ABG int A, int B, int C, int D, and I did a return a plus b plus c plus d divided by 4.0. So is this okay to have both be called compute ABG, right? If that is okay, in the technical terminology we say we have overloaded compute ABG, meaning there are 2 compute ABGs. So remember the rule we discussed was as long as the number of parameters or the type of parameters is different, you can overload as many times as you feel like it. So overloading is one form of polymorphism because we have more than one function with the same name. Okay? And once again, overloading is done within the same class. Okay? So within the same class, we have more than one function with the same name. As we discussed, we often overload constructors. That's very typical, right? What's the second form of polymorphism? Second form of polymorphism is overriding. Okay? So actually, let me do over here. Okay, overriding is done between a base and a derived class, right? So once we were doing inheritance, we've already discussed it, so you are already very good with overriding. You know, for example, when to use the abstract, when to use the virtual, when to use the override keyword, right? So once again, if I show you a quick example. So the overriding would be, again, you created some class called student, let's say, and whatever data you had, you did public string compute grade, for example, that you guys already did, right? And whatever the code is, right? Now we go create another class, public, not public, class grad student. Okay, and over here, so we mark it virtual over here. We do public override string compute grade, right? So now take a look over here. There's a compute grade over here. There's a compute grade over here, okay? Unlike overloading, where the parameters are different, here, even if either there are no parameters or even if they were parameters, the signature in overriding has to be 100% the same, okay? And as I mentioned, overriding is done between 2 separate classes. Here's one class, we inherit from here, and I forgot to say student, otherwise the inheritance will not make sense, right? And then we can override. So again, this is a type of polymorphism because we have 2 functions with the same name, okay? So now there's one key concept with polymorphism. Okay, so one of the key concept that we run into with overriding is when a base class reference is used to point to a derived class object. So we discussed the concept of vtable, okay? So that concept again is very important, and it only occurs when overriding is going on, okay? So now there's another small complication with whenever the base class and derived classes are involved, and we are using a base class reference to point to a derived class object. So let me give you one more example. So suppose you did something like this, public, let's create two classes again. Let's say class XYZ. Okay, suppose you declare two fields and the corresponding public properties, and public double compute. So just like before, suppose we wrote some function, whatever the code is, right? Now let's go and inherit from this one, and so if we did public XYZ and inherit from, public, let's call it PQR, inherit from XYZ, and suppose we add one extra C and we do an override, so let me mark it virtual, and we do an override double compute. Okay, so anyway, so now let's take a look at this scenario. Okay, suppose somebody creates one object of XYZ. Okay, however, one reference of XYZ, not the object. Okay, however, rather than creating an object of XYZ, they create object of PQR. So new PQR. So first of all, is this legal? Is this allowed?
Yes.
Remember, that's one of the fundamental ideas in object-oriented programming, that base class reference can point to a derived class object. So if this is inheriting from XYZ, sure, we can create a reference of this type and create the actual memory for the derived type. So it's perfectly okay, right? So now, suppose we do this. We say x1 dot a equal to 5. Yeah, that's fine. x1 dot b equal to 7. x1 dot c equal to 9. So you try to write this code. Okay. Up to this part will be fine. This part will be fine. As soon as you write x1 dot c equal to 9, you will get a compiler error. Okay, so the question is, why is that? Okay, see, if you are the compiler, how will you decide? You will check what is x1. X1 is XYZ. Remember the symbol table, as soon as we did this, there will be a symbol table created by the compiler. And in the symbol table, all variables that we are created are maintained and what data type they belong to. Okay, once the compiler comes to this line, it will say, oh, x1 is XYZ. So what will it do? It will go over here. Is there a C over there? No. So it will give us an error. Okay, however, we know that we allocated memory for PQR, and PQR does have a C in it. Okay, so this is a complication related to base class references and derived class objects. Okay, so the question is, how do we resolve this? Okay, so now let me introduce two new things which are related to polymorphism. So in C#, to support polymorphism, okay, we have three capabilities. Okay, what are those three capabilities? One is the is keyword. Okay, one is the as keyword. And one is reflection, which is a little bit advanced, but all three are needed for supporting true polymorphism. And when I say true polymorphism, that means once a base class and a derived class object is involved. So let me go 2 more minutes, at least clarify the introductory idea. In the next lecture, we will understand it 100%. So the way we will do that is, when we say x1.c equal to 9, okay, obviously this will not work. So however, we do want to set c to some value, so we will do something like this. If x1 is PQR. So using the is keyword, we'll try to determine, think of it this way, we are checking is x1 pointing to an object of the PQR class. Okay, if that's the case, then we will do PQR P1 equal to x1. Okay. So now we will create a reference of type PQR and make it point to the same place x1 is pointing to. See, if I draw the picture, it will be a lot clearer. So let's say here's the CPU, here's the memory. Okay, so let's go to the top line. We declared x1. New PQR, so how much memory will be allocated for PQR? 3, A, B, and C. So this is pointing over here, correct? And of course, there's a V table also. Okay, so anyway. So now let's take a look over here. x1.a will end up putting 5, end up putting 7, no problem. This will not work. Like I said, compiler will not recognize C, so we will make this check. Okay. So now, when we say x1 is PQR, internally what the computer does is, it will start from x1, go to PQR, then locate the V table, go to the V table. Okay, remember there for every class there's a table of function pointers, right? Okay, now let me introduce one extra part over here. There's one more memory maintained for every class in the code area. So in the code area, there is also type info for each class. So for every class, there's a single information called the type information. Okay. What does type information contain? It contains many things. It contains, for example, name of class. For example, it will say PQR. It will say how many name of first field. Okay, for example, A, name of second field, name of method. So each and every detail about the class, how many variables it contains, what are their names, what are their data types, what are the methods, what parameters they take, what do they return, if we have any interfaces, what are those interfaces, what are their names. Every detail is maintained for one class, so this will be, for example, type info for XYZ class. Very similarly, there will be a type info for, so very similarly, there will be a type info for XYZ class, right? So the last entry in the V table is a type info pointer. So this type info pointer will point over here. So now take a look, how does the computer know X1 is pointing to PQR? It will start from X1. We'll go to the V table, and then from V table, where will it go to? The type info pointer, and it will check what's the name of the class. If it is PQR, it will come back as true. Okay? So now let's go to the next statement. Now we are saying let's create a reference P1 of PQR. So what will the computer do? Create a reference P1 and make it point to same place X1 is pointing to. So we'll also point to same place X1 is pointing to, right? Okay, however, there's a tiny problem. C#, like Java, is a strongly typed language, meaning the data type of the left side has to match the data type of the right side. What's the data type of the left side?
PQR.
PQR. What's the data type of the right side? XYZ. They do not match. So compiler will not let you compile it. So for that, we have a concept called typecasting. So we will say, before we assign it, change X1 to the PQR type. So now the left side is PQR, right side is PQR, so this is called typecasting. So to satisfy the compiler, we will change the type of X1 to PQR. Now this is safe typecasting because we've already verified up above that X1 indeed is pointing to PQR. So it's okay to change this, right? So now P1 is pointing to the same memory, but P1 is of what type? PQR type. So if I did P1.C, will the computer recognize it? Again, P1 is PQR. It will go to the class called PQR. Is there a C over here? Yes. So now you can set it to 9. And through P1, if you call the compute, it will work perfectly. Okay? So that's the concept related to polymorphism. So I explained the is keyword. Next time I'll explain the as keyword and the reflection. But the key thing to remember is there's nothing magical. Everything has to be stored in the computer so that we can find out how exactly, what type of object it's pointing to. So having a clear idea of the memory, how it's stored, will help you understand these concepts nicely. Okay? All right, we'll continue from here.